All right. Before we get started, I want to give a quick shout out to our sponsor at Vaco. Spinman at Vaco. He's been sponsoring us from almost day one, and we couldn't have this meeting without them. They pay for our meetup.com fee, which is bi-yearly. It's $98 every 6 months. So a huge shout out to them. If you're looking for a tech job in the industry and you've already had about 3 years experience, they're great people to talk to. Spinman, he is in our Boro.Dev Slack, so you can reach out directly to him. And without further ado, let's go ahead and let Nathaniel. I'm gonna let you do a little more introduction. I know you already did a majority of it, but we didn't get it recorded. So for those who
Yeah,
are watching later, go ahead and introduce yourself, and then share your screen. Go ahead and share your screen and see if we can get that going first, and then you can introduce yourself.
boom ban. Okay, y'all should be able to see it
Awesome.
now.
Yep, it's starting to come through. Sweet. All right, it's all yours.
Perfect. Yeah, well, hey everybody. I am Nathaniel Schweinberg. I've been in software for the last 10 years or so. Actually got started using WordPress. I was a front-end engineer for a number of years. Then as my client demands increased, I learned more and more of the stack, became a back-end engineer, eventually a full-stack engineer, and then I've been in DevOps for the last 5 or so years. I'm an AWS certified SysOps administrator, so I deal a lot with the backend operations using AWS systems. I'm currently employed by a company called Noop, where we are striving to reduce or remove any operational knowledge from deploying applications. So if you ever need to deploy an application using databases and microservices, our product will be designed to facilitate that without any need to know operations on your part. So we haven't entered beta yet. We're hoping to do beta by the end of the summer, but we shall see what happens there. So yeah, so let's go ahead and get into it. So one of the first things that I want to do is set some definitions up so that we're all operating on a shared understanding of certain things. So the name of the talk is Scalable, Highly Available Infrastructure in AWS. So that first term that I want to define is scalability. And scalability refers to the ability of an infrastructure to change its size on demand. And there's two kinds of scaling. There's vertical scaling, where you increase a server's CPU or memory or disk space up or down. And then there's horizontal scaling, where you add more things to your infrastructure. So, or more of a single thing. So if you need to add more servers or more load balancers or more databases, that's what you do with horizontal scaling. Our second term is high availability. High availability refers to an infrastructure's ability to continue serving requests when resources are no longer available or have failed. So the best way to illustrate this is, let's take an example. Let's pretend that we have a site called humanseatcake.com. And this kind of represents the most basic hosting environments, DreamHost, Bluehost, etc., where your website is served on a single server. And the problem with that is that if that single server ever goes down, you're kind of up a creek, because now the one place that was serving all of your content is gone. Another term for this is a single point of failure. A single point of failure refers to a resource or access point that, if it fails, prevents the application from serving requests. So if you want to remove a single point of failure, you would add multiple copies of your servers. And what would happen is that if one of the servers ever goes down, you actually still have two more that are able to serve the content without any loss in service. So I want to talk about two problems that growing sites face, and those are overwhelming load and servers failing. And most often, overwhelming load leads to servers failing. And so I'd like to present what solutions AWS provides to solve these problems. So the first challenge that we face when we go from a single server to any number of servers above that is routing. How do we route traffic to more than one server using one domain? AWS's solution to that is elastic load balancers. What elastic load balancers allow us to do is put all of our servers behind a single resource. So in this case, we have a elastic load balancer, which is exposed by a DNS address, which will then handle routing all the requests made to the load balancer to all of the different servers. Looking at that graph, though, you might be thinking, well, now we've introduced another single point of failure, the load balancer itself. And that's where AWS steps in. AWS's service manages hosting multiple load balancers on our behalf. And so that one DNS address that they give us will actually be fronting more than one IP address. So I've seen it anywhere from 2 to 8 IP addresses being attached to a single DNS name provided by AWS. So that way, if any of their load balancers ever go down, they will either spin up a new one, or they have other load balancers that are available to serve the traffic. And they handle all the hot swapping on your behalf. One of the next challenges is now that we've introduced more than one server, deploying the application is actually significantly more difficult, because before you may have been able to use FTP or SSH just to copy your code directly to the server. But now if we have more than one server, it is now considerably more complicated to deploy those updates, ideally at or around the same time to all the servers. So how do we deploy our code to multiple servers at the same time? AWS's solution to that is something called Code Deploy. Code Deploy is a service that sits alongside all of the servers and will actually take n number of servers out of, they'll detach them from the load balancer and copy a zip archive or tar or whatever to the server itself, and do that for each group or individual servers without you ever having to manually do that. So the nice thing about this is that they'll automate with the use of scripts, disconnecting the server that it's deploying to from the load balancer, so it's no longer receiving traffic, which makes it safe to be able to replace any code running on that server, and then reattach the load balancer whenever that deployment for that single node is done. Code Deploy also offers multiple deployment types. So the one that I've used in my job is one at a time. You can also do all at once or percentage based. So for instance, one at a time, if you don't have a bajillion servers running, you can safely replace it one at a time. That'll take a little bit. Or you can do it all at a time. I wouldn't necessarily recommend that, because that could lead to a catastrophic failure. But all that to say, there's multiple ways to deploy to multiple servers at one time. Again, another challenge that arises from moving from a single instance is, where does your database live? And more specifically, if your database lives on one server, that's still a single point of failure, and we need to expand that to something else. So how do we ensure that our database itself is highly available? Well, AWS's solution to that is the relational database service, specifically with multi-AZ enabled, either RDS explicitly or their own database engine called Aurora. And the way they're backed is pretty similar. So whenever you use RDS, all of your servers will connect to a single DNS address that they expose, either the read and write endpoint or a read-only endpoint. And behind that endpoint will be any number of servers. Specifically, if it's for RDS with multi-AZ, it will be one instance per availability zone that you can configure. It's recommended to do at least 3. You could do at least 2, but if you do 3 availability zones, you'll have a redundant. And what happens is that if this master server ever goes down, that's the one that's usually serving all the traffic. If that ever goes down, AWS will actually promote one of the standbys to be the new master, and there'll be a small period of downtime, usually less than 60 seconds, and then destroy the server that failed, spin up a new one, and then that one becomes a new standby. Aurora is very similar. It'll have n number of instances. Some of them you can configure to be read-only instances, and they're all backed by I don't know the proper term, but I'm just going to call it. Actually, it's basically S3 if you're familiar with their block storage service. But they have servers sitting in front of a storage backend, and they give you a read and write endpoint and a read-only endpoint, and they'll also do this same rotation. So one of the other things we need to handle whenever you're scaling to more than one server is, how do you save money in this? You don't want to just scale up to 8 servers all the time, because that'll be very expensive very quickly. And in our scenario here that's outlined is, what happens if we hit the front page of Reddit and we're flooded with traffic all at once? How do we respond to traffic without manual intervention? AWS's solution to that is a service called autoscaling. And autoscaling is available for multiple of their services. For instance, there's EC2 autoscaling groups. There's autoscaling for their ECS service, which is their Docker solution. There's autoscaling for RDS and Elasticache, which is their in-memory solution. And what happens is that, let's say that we have 2 servers running in our EC2 autoscaling group. We set a alarm to go off whenever the average CPU utilization for all of our servers is greater than or equal to 80%. And whenever it crosses that threshold, we want it to perform an action. In this case, add a new server. But then let's pretend that, or no, yeah, let's pretend that we've now increased to 3, but our CPU level drops and it's below another threshold, in this case 40%. What we can do is also tell it to remove a server and then bring it back down to 2. So what's nice about this is that you can operate with 2 servers. You can set your auto-scaling group or whatever service. You can set your auto-scaling group to a minimum of n number of instances and a maximum number of n number of instances. So that way you put boundaries on how far out you want to scale and how far in you want to scale. So that way you always have a minimum amount of minimum number of servers to be available without ever going past a certain point, so that your bank account isn't totally drained. Finally, one of the other solutions that we need to come up with is, how do we share configuration updates across all of our servers? We don't want to be SSHing into 50 or 100 servers to update an Nginx config or some other configuration. We want to be able to propagate those changes in an automated way without risk. So AWS solution to this is Amazon Machine Images, or AMIs. Similar, if you're using ECS, would be Docker images. And what this does is it allows you to package a server's file system into a single artifact and then configure their EC2, configure EC2 to deploy from that single artifact. And so that way you can package up your configuration in a single artifact and then share that across any number of servers all at the same time. In this way, this is something, there's a philosophy called immutable infrastructure, where you don't want to be changing configuration on your servers on the fly. That introduces something called server drift. And if any number of your servers get out of alignment with the rest of your infrastructure, things can misbehave. Errors can happen, or if there's very odd behavior, it makes things confusing, because now some of your servers are configured one way and the rest of your servers are configured another way. And that makes it difficult to debug, because you don't have consistent behavior. There's no deterministic way of knowing, if I make a request to /foo, it will always behave a certain way. That's not guaranteed. But if you're using immutable infrastructure, using images and such, using images, for instance, then you can always guarantee that the behavior of your infrastructure will be consistent, because they're all configured in the same manner. So as our traffic increases, for example, from more than 100 requests a minute, thousands, tens of thousands, how do we make sure that our database isn't overwhelmed? It's very easy for a database, especially if it's not configured well, to be overwhelmed. How do we minimize queries to the database while still serving fresh content? AWS solution to this is Elasticache. Elasticache is their in-memory database solution. Memcached or Redis, if you've heard of those. And what that does is it provides a intermediary between your application and the database. Or another way of saying it is that it's a separate database that's much faster at retrieving data than a normal database is. And just like RDS, all of your servers connect to a single Elasticache instance exposed by a single DNS address, and AWS handles all the auto scaling for the service on your behalf. So if one of the instances ever goes out of service, they'll replace it for you, and you don't need to worry about that at 3 a.m. So finally, there's kind of a bunch more questions to ask. How do you automate building your AMIs? How do you spin up additional infrastructure? Do you use infrastructure as code tools like Terraform or CloudFormation? And before you even get to the point of overwhelming load, how do you reduce server load? For instance, using a content delivery network like Fastly or Cloudflare or CloudFront to cache as much information out on the edge before it ever reaches your servers. Thanks. That was fast, but I wanted to make sure there was plenty of time for questions, because I found it a lot more engaging. So, anything I can do, I would love to talk to you about it.
Sweet. Tanvir, you got a question?
Yeah. So one of the things that surprised me was, you mentioned that deploying applications itself can be more difficult than something else. Was it setting up the load balancer itself for your site?
No, so whenever you go from deploying from one server to multiple servers, it can be difficult to orchestrate getting that artifact to multiple servers at once, if you're not familiar with that, or if you don't have that the tools to support it.
Do any of you have experience with that difficulty, deploying applications to multiple servers?
Kind of, yeah. So I mean, it depends on what tools you're using. If let's see, for instance, AWS solves this problem. It kind of depends on what tool you're using to actually host your infrastructure.
Okay.
AWS is not very batteries included. They expect you to configure a lot on your behalf.
Right.
But if you're using a platform like Heroku or Netlify, they make it very easy to do that. In that you just git push something, and they'll handle all that deployment stuff.
Okay, thanks.
Yeah.
Yeah, so I have a quick question.
Mhm.
So similar to AWS, you have Microsoft Azure. So
Yep.
what would you say is one of the advantages or one of the ways in which AWS is leading Azure, and what would you say is one of the ways in which AWS is lacking behind Azure?
So I'm not personally familiar with. Let's see. Okay, actually no, I do have examples. Ways that I find AWS is better than Azure is global, like the number of data centers they have. AWS is freaking everywhere, and they're constantly expanding. And they have a ton of edge nodes for their own CDN, which means, okay, actually, sorry, I'm a ramble for a bit. Because AWS has so many data centers, they also have a ton of edge nodes, which means they have data centers all over the place for you to get into their network. And as soon as you're in their network, they have a ton of actual physical hardline going across the world that makes it a lot faster to serve requests. So trying to figure out a better way to say this. So if you're hosting with I'm gonna pick out Bluehost for arbitrary reasons, and you live in Finland, and their data centers are in the U.S. That traffic has to go from your house in Finland to your ISP, then to some international hardline to get to Bluehost's data center in the US.
Right.
In AWS's case, though, because they have points of presence already in Europe, like if you make a request to something within AWS's data center, they'll ingest you into AWS's network in Europe and then send you across their own hard lines to America. So the latency in using AWS is lower. So all that to say, AWS has more points of presence, which means you get into their network faster. And I don't think Azure has anywhere near the number of points of presence that AWS does. AWS also integrates really well with a lot of their own services. Really well and terribly at the same time, because it can be a pain in the butt to manage permissions. Things that Azure does better, I would say Azure, I think they were first to market, at least amongst the big hosting providers, for functions as a service. Like they had Azure functions as a service before, or excuse me, containers as a service, well before Amazon had even launched Fargate, which is their solution for containers as a service. So also Azure, they have an exclusive license to GPT-3. They're the only cloud provider allowed to use that AI model. So that's kind of my ramble on it.
Thank you so much for sharing.
Yeah.
Awesome. Any other questions?
I have
So-
one more in mind.
Yeah, go ahead.
Yeah.
So how do these different load balancing providers or cloud host providers differ in terms of price? Because different providers are nice on different levels with their technology, but there may be of course, a performance cost with choosing the cheaper option. I wouldn't know.
Right. I mean, AWS flat out expensive. They are.
Okay.
They are. What do you say? So that they'll charge you for the instance itself, and they'll also get you on bandwidth. And AWS is for, let's see, what am I saying? What am I saying?
So would it be expensive in terms as the number of traffic? I mean, I wouldn't know. How does AWS get expensive?
Right. So specifically, they have LCUs, and I forget what that. I think that's load balancing compute units, and effectively that is how many. Let's see. I'm trying to remember what the actual equation is. It's however many instances they have running in the background over the entire duration of the month. They have that, And they also charge for the bandwidth coming in and out of the load balancers. So not only are you hit with basically a minimum fee for how long you have your load balancer running, you're also hit with all the bandwidth that comes in and out. And AWS, that's kind of one of their big margin money makers, in that bandwidth can get very expensive internally. So one of the ways that organizations will combat that cost is by pre-purchasing bandwidth. So for instance, we would buy bandwidth at my old company for CloudFront in bulk, like tens of thousands of dollars all at once, to save a pretty significant chunk of change over the year. The other strategy to that is using CDNs, and that hits on one of the last questions of like, well, how do you reduce load, period? And that's just don't serve any traffic if you don't have to. If you can push out serving that traffic to the edge, to points of presence, using CloudFront, Cloudflare, Fastly, other CDN providers, then your infrastructure doesn't ever actually need to serve anything, because it's been served at the edge, closer to the customer. So let's see. Unfortunately, I don't know Azure's pricing. I'd be curious about DigitalOcean. Like, they're a pretty popular, smaller hosting provider. Super developer friendly. Like, they have incredible documentation, and they've been slowly building up their managed services. And I know that load balancing is one of the ones that they've launched recently within the last couple of years. And I'm coming to a blank there. That's all I got to say about that.
Thanks for the detailed
I
response.
have two different questions. The first one
Yeah.
is, do you think Azure provides very good documentations for all of the integrations compared to, let's say, other cloud providers like Azure? Then you have Google cloud providers and stuff like those. And the second question I have is, when you have a point of failure, you basically say between the supporting servers, you basically choose a new master, and when you choose it, there is a 60 seconds or less than 60 seconds delay. So my question is, it's more related with hardware, a little bit related with security as well. So my question is, when you choose the next master and during this specific delay process, do you think the system is prone to side channel attacks, or say spectre attacks, or some sort of cache channel attacks, or cache template attack per se?
That's an interesting question. So the first one.
So I don't probably know, so I'm just asking to understand.
Right. I'm so sorry. I actually, let me answer your second one first, and then we'll go back, because I forgot the first question. I'm so sorry.
Okay,
so I'll admit I'm not super security great on that. But side channel, from what I understand about side channel, it's effectively, or at least maybe I'm thinking about timing attacks. Is that closer to what?
Yes.
Yeah. Okay. That's a good question. Off the top of my head, I don't think so, simply because the resource would be unavailable, and unless you have some sort of caching mechanism or pooling mechanism to hold on to requests that would be malicious, like, you would have to have something that's malicious in somewhere to then take advantage of that. Like, or so I guess it kind of depends on how your application is structured. Does it fail quickly? Like, if the database is unavailable, it just serves a 503 or a 500 or something like that and says, I'm not able to do anything. Or in the case of some providers, they'll hold on to a request while they're waiting for a resource to come online. For instance, example, Heroku, their free tier, they will shut down what they call a dyno, a container, effectively, to save cost. And whenever you make a request to dyno that's been shut down, their load balancer will buffer that request. It'll hold on to it and wait for the dyno to spin up. And then once that's healthy, it'll let the request through and reach the dyno and then serve the response. Unless you're doing something like that, I don't think a timing attack would do anything, simply because it's not able to go anywhere to affect anything. Remind me what your first question was.
So my first question is, during your presentation, you did say AWS is harder to integrate or install. I think that's what you said. So
Right.
my question is, do you think AWS right now has enough documentations to make the process easier compared to, let's say, other cloud providers?
Right. Okay. So my impression that I've gotten just from reading is that Azure isn't great and Google Cloud is somewhere in the middle. That said, that's just my impression. I've never actually seen their docs to know. That said, or I can speak to AWS though. AWS has really good docs in some places, but horrendously lacking in others. For instance, knowing what IAM permissions to assign to a role to allow resources to perform actions, horrendously lacking. Like you have to, there, it is, I have often had to spin up a service and monitor CloudTrail to see what permissions are being requested in order to add those permissions to the role or identity I'm trying to grant those permissions to, which is infuriating because I don't know that this is not a great experience. I'd much rather than be able to say, if you want to do this, these are the permissions needed for the service. And they've started doing that in some places, but it's definitely not all over their documentation. Yeah, so it's been good in some places, lacking in others.
That makes sense. Thank you. Thank you so much. Really appreciate
Yeah.
it.
Awesome. All right. Well, let's we'll go ahead and close this. I'm going to stop the recording now. Thanks again, Nathaniel, for giving the talk, man.
Yeah.
Yes, thank you.
Have a
Thanks,
good day,
Nathaniel.
Sean.